Motilal Gandhi, Professor and Head of Mechanical Engineering Department, Barry's Institute of Technology, Mangalore. Today I am going to discuss some important problems on properties of fluid. It is a problem statement. I read the problem statement. The velocity distribution of flow over a plate is parabolic with a vertex 30 centimeter from the plane, where the velocity is 180 centimeter per second. If the velocity of fluid, if the viscosity of the fluid is 0.9 Newton second per meter square, find the velocity gradient and shear stress at a distance of 15 centimeter and 30 centimeter from the plate. Say this is a plate, right? It is a plate and a velocity distribution plot is making parabola. It is a velocity distribution plot. It is making parabola, right? Nature of that is parabola, and vertex is at y is equal to 30 centimeter, right? So velocity is maximum at 30 centimeter from the plate. It is a plate, right? It is a y is equal to 0. Here there is a plate, and maximum at y is equal to 30. This is the fluid uh, height in over the plate, right? So when y is equal to 30 centimeter, velocity is maximum, that is u is equal to 180 centimeter per second, right? This he has given. Moreover, he has given viscosity of the fluid mu is equal to 0.9 Newton second per meter square, and he is asking us to calculate, what is asking us to calculate? Velocity gradient, that is du by dy, and shear stress, right, at a distance of 50 centimeter and 30 centimeter from the plate. This is what the thing is asking us to calculate. Find the velocity gradient, that is du by dy, and shear stress mu is asking us to calculate. It is a problem statement. It is given data. Right? And let us find how to find the solution for this. Okay. Now we know the problem statement, and here it is solution for the problem. In the problem, it is stated that velocity profile plot is a parabolic. So parabolic equation I have taken. It is a velocity. Velocity is a parabolic, right? Velocity distribution is parabolic. We know parabolic equation for velocity. If velocity is indicated by u, then u is equal to ay square plus by plus c, right? Where a, b, c are the constant. These values can be determined. These constant values can be determined by substituting the boundary condition. First boundary condition I substitute. U is equal to 0, y is equal to 0. Means on the plate, it is over the plate at this point, right, velocity is 0. Velocity is 0, y is equal to 0. It is on the plate, right? There is no velocity at all, and distance is also 0. That I substitute in this equation, right? Velocity distribution curve, I substitute that value. If I substitute that value, I am going to get c is equal to 0. U is equal to 0. U is equal to 0. I substituted here. I substitute value of a y square, 0 square, y is equal to 0, plus b, again y is equal to 0 plus c. So from this I get c is equal to 0. Right? Similarly, I apply the second boundary condition. What is second boundary condition? Second boundary condition is here, right? When y is equal to 30 centimeter, it is a vertex, right? Vertex means where maximum velocity you find. Y is equal to 30. Maximum velocity is 180 meters per second. It is 30 centimeter. That value I substitute in the same equation, this equation only. So I substituted here. It is the AB value after substituting the y is equal to 30 and u is equal to 180 meters per second. It is the third boundary condition. It is important to understand here. What is third boundary condition? Du by dy is equal to 0 at y is equal to 0. Means here it is maximum at y 30 centimeter, velocity is maximum, right? That is 180 centimeter. Further, if you increase the velocity increment with respect to distance is 0, further it will not increase. That is what du by dy is equal to 0 at y is equal to 0. Further this is not going to increase, right? The increment at this is 0. That is what the statement. And du by dy I obtain from this equation. I differentiate the parabolic equation, velocity equation is there, no? That I differentiate. I differentiate that this equation. I am going to get du by dy is equal to equation of this. It is 2ay plus differentiation of this is just b, and differentiation of constant is 0. So this is going to become, if I differentiate, du by dy is equal to 2ay plus b, right? So next what, right? So same thing I wrote here, velocity change is up to y is equal to 30 centimeter. Further there will be no change, means du by dy is equal to 0, right? At y is equal to 30 centimeter. This is the boundary condition I applied here. So what, if I substitute this value, y is equal to du by dy is equal to 0 at y is equal to 30, I am going to get this equation. I am substituting this equation, 2y is equal to b is there, 2ay plus b is equal to du by dy is there, that equation. Du by dy is equal to 0 is equal to 2, a value is 30 we obtained, sorry, what, du by dy is equal to 0, and 2 to y is equal to 30 centimeter, a unknown, b also unknown. So we got here b in terms of a. If I simplify this, b in terms of a I got. There is, in second boundary condition we had this equation. In this equation I substitute the b value, right? This value I substitute, so that I get the value of a here. This is the value of a. Okay. So I simplify the equation. Once if I simplify the equation, I get the value of a is equal to minus 0.2, right? So further what, same this value, there is a b relation. I substitute this way value in the previous equation, so I get the b value also. B is equal to 12, right? So I got the value of a, b, and c is equal to 0. Those values I substitute in the equation, right? A velocity gradient is asking, that is du by dy at 15 and 30 centimeter is asking. So du by dy at 15 at y is equal to 15, I substitute the value, 2 y is equal to 15, a is equal to value I know, a is equal to minus 0.2, that value I substitute, plus, right, in this equation b value, b is 12, if I substitute I am going to get the du by dy value. Okay, du by dy value is obtained here. And is asking us to calculate shear stress also. Shear stress is equal to mu into du by dy, right? This is the value as given, viscosity value as given, mu is equal to 0.9 as given, du by dy value we know, right? That is 6 for y is equal to 15, right? Those values I substitute for y is equal to 15, that is 6. So I substitute those values, so that I get the shear stress is equal to 5.4 Newton per meter square. It is a shear stress. Similarly, I calculate du by dy at y is equal to 30. Du by dy at y is equal to 30. Du by dy equation I have 2 a y plus b. This is the equation. In that equation I substitute the values. I get what? That is equal to 0. 0. Right? Du by dy is equal to 0. It is unit per second. It is 0. This value again I use to calculate the shear stress. Shear stress also I have to calculate in the both the conditions. Shear stress is equal to, I have to calculate. So mu is equal to 0. I substitute mu is equal to 0. Once you substitute mu is equal to 0, shear stress is going to become a 0. Right? So it is a 0 Newton per meter square. This is how we can calculate the velocity gradient and the shear stress, right? When in case of parabolic velocity distribution, when mu is given. Okay, it is the second problem. Right? I read the problem statement. An oil film thickness 1.5 millimeter is used for lubrication between a square plate of size 0.9 meter into 0.9 meter. Slides down an inclination plane having an inclination of 20 degree with horizontal. The weight of square plate is 392.4 Newton and it slides down the plane with uniform velocity of 0.2 meters per second. Find the kinematic viscosity of oil and specific gravity of oil. Find the kinematic viscosity of oil. Specific gravity of oil is 0.7. This is given, right? So he is asking us to calculate kinematic viscosity. Specific gravity is given. First, you write a free body diagram for the given statement. Here I wrote the free body diagram for the given statement, right? So what is said in the problem? There is a square plate sliding over a plane. It is a plane. This plane is making 20 degree with the horizontal. This is given in the problem. And weight of the plate which is sliding over the plane, that is also as given, that is 392.4 Newton, right? And this film thickness U is equal to, this film thickness T is equal to, T given. Sometimes we take that as a Y also, right? T is equal to 1.5 millimeter. This is the film thickness. The thickness film is between this plane, right? It is a sliding plate. Sliding plate is sliding over a plane. In between that two, right, there is a film thickness. That thickness also he has given, that is 1.5 millimeter. This is the problem statement. This is given data, right? And D is asking us to calculate what? The kinematic viscosity of oil. So you just here force diagram we have to write. Weight is 392. It is very important to understand. Effect of this 392 weight, effect of this weight along the sliding plane we have to calculate. Means we have to calculate here. It is 20 degree as given. The free body diagram I wrote here. It is a weight acting in downward direction. It is a plane, and right, it is a plane. Along this plane, the plate is sliding. Plate is sliding down. Am I right? This plane is making 20 degree with the horizontal. This is horizontal line, right? If it is making 20 degree, this is the 90 degree. It is 70 degree. If it is 20 degree, it is entire angle is 90. Am I right? This is horizontal. It is vertical. It is 90 degree. And if it is 20, it is 70 degree. It is 70 degree. Means weight is making 70 degree with the plane on which the plate is moving. Right? If you draw a line here, vertical line, if it is 20 degree, here also we can calculate. This is the 70 degree. It is 90. It is 20. That is 110. 110. If it is 110, 180 minus 110 is the 70 degree. It is 70 degree. This angle we have to calculate. Not only this angle, right? Effect of this weight along the sliding plane, that also has to be calculated. This, how you calculate effect of this along this plane, effect of this weight, vertical plate along this plane, how you calculate? It is very simple. Use a simple trigonometry. If it is 70 degree, right, cos 70 is equal to adjacent side effect of this, that is unknown, x, divided by the opposite side. Opposite side is 392, that weight, whatever weight is there, 392.4. So that we get the value of x, that I have shown in the next slide. Okay. Here I made the note of given data. Oil film thickness as given, that is dy or t, whatever it may be. I consider that as a dy, right? That is 1.5 millimeter. That I convert in terms of meter. Square plate of size as given, 0.9 into 0.9. That I just find out the area. Right? Square plate of size, both the side as given. From that I can calculate the area. That is 0.9 into 0.9. How much? That is 0.8 meter square. Right? Inclination of the plate as given with the horizontal line, that is 20 degree. Uniform velocity of the plate. Plate is moving with 0.2 meters per second, right? 0.2 meters per second. And effect of the weight along the direction of moving body, that we can calculate cos 70 is equal to x by w, x by w he has given, weight he has given, so x is equal to cos 70 into this weight. Okay, so that we get the x value. Once if you know the x value, that is weight along the direction of motion, right, then we can calculate, we know the area also, area of the plate also we know. Shear stress is equal to shear force divided by area, right. The shear force we calculated, x is nothing but the shear force, that x shear force divided by what, cross sectional area of the plate. So shear stress we get, that is 165.7 Newton, right. So you just what, you substitute the shear stress value, du by dy value also we can substitute that given, and we are going to get the value of mu. Okay, from this we got the value of mu. Mu is equal to 1.2 Newton second per meter square. So we have one more equation, that is specific gravity, S is equal to density of fluid divided by density of standard fluid. Density of standard fluid is a water, that density of standard fluid is 1000 kg per meter cube, right. And density of the fluid, oil film, that we don't know, right? That has to be calculated, right. It is specific gravity as given, that substitute the value of specific gravity, this density of fluid we can calculate. So density of fluid is 700. What is that? Kg per meter cube. Unit is kg per meter cube, right. We know kinematic viscosity. Once if you know density, kinematic viscosity is very simple. Kinematic viscosity is equal to viscosity divided by density. Viscosity we know 0.12. Density of that oil also we know, that is 700. If you substitute the value, right, we get what? This is the answer. It is kinematic viscosity is equal to 0.0017 meter square per second. Okay, this is how we can calculate the kinematic viscosity.